In this video, we're going to take a look at creating linear models for real-world situations. In other words, applications of linear equations. One application of linear equations is using the slope of a line to model real-world scenarios. The slope represents a rate of change. Some examples that you might be familiar with would be velocity, like miles per hour or meters per second, cost per unit, and then of course population per year or some other increment of time. So we'll take a look at three examples in this video. As we read, we want to understand kind of what's going on in the problem again. So we may need to read a couple times. We'll underline some key information. Make sure to box the question that's being asked as we go to develop our model. A barrel rolls down a 400-foot incline. After 2 seconds, that barrel is rolling 6 feet per second. But after 3 seconds, it's rolling 9 feet per second. T is going to be time in seconds, S is going to be speed. And we assume that the speed of the barrel will be increasing at a linear rate. So, to break this down, the first step here asks us to find two ordered pairs in the form time and speed. And again, those variables were defined as T and S. So as we look back at our problem, 400 feet is the incline. Then they tell us that 2 seconds the barrel rolls 6 feet per second. Well, that was a time and a speed. So that's going to be our first ordered pair. 2, 6. The second ordered pair comes in the next sentence, where they give us a time, 3 seconds, and a speed, 9 feet per second. That answers portion A. B now asks us to find an equation in slope-intercept form to represent the relationship between time and speed. So slope-intercept form is what we're looking for, y equals mx plus b, or in this case, s equals mt plus b. So we need to first find the slope, as we did earlier in previous videos. So m equals 9 minus 6 over 3 minus 2, which is 3 divided by 1, or a slope of 3. We're going to use then one of those points in point-slope form to find this equation. Y minus 6 equals 3, the slope, times x minus 2. And I use this first point. But again, you could have chosen the second point. And here we go. Distribute the 3. And they want this to be in slope-intercept form. Well, again, the s will be in the place of y, so we can say s now. We'll add 6 to both sides and have 3x. Well, the x is actually going to be t. And negative 6 plus 6 is 0. So in slope-intercept form, s equals 3t. Technically plus 0 for the y-intercept, but we don't need to write that. So this then would be the answer to question B, part B. Finally, use the equation to find the velocity after 5.5 seconds is the ultimate question here. So they gave us a time to substitute into our model. S equals 3 times 5.5 seconds for a final speed of 16.5 feet per second. The units are very important in these questions because it provides meaning to our number answer. 16.5 or 16 and 5/10 or 16.5, that's really meaningless in this situation without the units. Was it a time? Was it a speed? How fast was that speed? Those questions all need to be answered. So make sure to include units with your answer. Question 2. In 1990, the population of a country was 45,000. That's our initial population here, 45,000. In year 2005, the population was 60,105. Let X represent years past 1990. And that is so important. We're going to talk about that in a little bit. Let's see, this I missed. The population in 1990 was 45,000. Okay, and then Y is going to be the population. Assume that the population of the country grows at a linear rate. We're going to use the above information to answer the following. Again, they want two ordered pairs. They tell us that the X is the years past 1990 and that the population was Y. Looking back, 1990 was the year. So X is not 1990. That's what students want to write often. Remember, it's years past 1990. Well, if we're talking about 1990, we're 0 years past that, and the population was 45,000. The second point is the year 2005. That is 15 years after 1990, so X will be 15, and the population 60,105. They want an equation in slope-intercept form. Again, y equals mx plus b is the form that we're looking for. This was our answer to part A. We need to find the slope first. 60,105 minus 45,000 divided by 15 minus 0. $15,105 divided by 15, we get a slope of 1,007. Using point slope form to get there, we substitute what we know. Y minus, and I like the point that has the 0, it's going to cut a step down, so we'll say 45,000 equals 1,007 times x minus 0, or just x. Here we can add 45,000 to both sides. We'll put our model up here. Y equals 1,007 x plus 45,000. I just noticed I had an extra 0 in our problem over there. Everywhere else it was correct, so hopefully you caught that mistake. And now this was the model asked for in Part B in slope-intercept form. Finally, they want the population in the year 1997. I can't substitute 1997 in for x representing time. I have to substitute how many years past 1990 the year 1997 is. That's going to be 7 years. So we substitute 7 in for x. And when you do that arithmetic, you get 52,049 people in the year 1997. That is the estimate, assuming linear growth. Example 3. A toy company developed a new action figure after 4 months of being available for purchase. The company sells 52,000 figures after 4 months. After 7 months, the company sells 91,000 figures. X represents the number of months of the action figure being available, and Y represents the number of thousand action figures sold. So we assume again that the relationship is going to be linear. Two ordered pairs. X is the months available, and Y is in thousands of figures sold. So we got to find our ordered pairs. Again, each sentence will give us an ordered pair. The first sentence that talks about it is 4 months. That's a time of months available. That's our X. Included in that same sentence, they tell us 52,000 figures. Since Y is written in terms of thousands, we're going to just stop with 52 instead of writing out 52,000. The second point is 7 months available and 91,000 figures sold. Part B asks us to find an equation, again in slope-intercept form, that represents the relationship between months available and thousands of figures sold. We find the slope. 91 minus 52 divided by 7 minus 4. And that's 39 thirds, or 13. Point slope form, y minus 52, because that's the point with smaller numbers, so that's what I'll choose. But again, you could choose the other point, equals the slope times x minus 4. We distribute 13. 13x minus 52. We'll add 52 to both sides. And we're left with y equals 13x. That's in slope-intercept form to satisfy the request of Part B. Finally, Part C says after 11 months, x again was the months available, so y equals 13 times 11 months will tell us how many thousand figures sold. 13 times 11 is 143. Again, units are important. If we just said 143, even if we said 143 action figures, we would be incorrect. See, y is represented in thousands again. So this is 143,000. And you can write the word here, or actually, comma and 3 zeros on that number. That would be okay. Figures sold. to answer part C. Mathematical modeling is a very important skill where we take real situations and turn those into mathematical models or algebraic equations that we're able to solve to use to make predictions. This is a very common thing in community planning. This is very often used in business as well. Just another couple examples. And as you begin in your math journey to learn about other different equations, like quadratic equations, exponential equations, etc., you'll begin to learn other ways to model mathematically with those other equations that will be useful in the future. So this introduction hopefully was helpful to you as you begin mathematic modeling.